Question number 36. The spin-only magnetic moment of M2 plus is equal to 5.91 Bohr magnetons. The metal M belongs to the 3D transition series, and we have to identify the metal M among the following given options. So if we look at the mu value, it is given to be equal to 5.9 Bohr magneton. So we can say that there are 5 unpaired electrons in the M plus 2. So if we talk about the metal M, it should have a 4s2 3d5 configuration. It means that the metal M should have a total of 25 electrons present. So the Z value is equal to 25 and the metal M is manganese. Students, for this question we have to select option 1 as the correct answer. Let us look at the next question. Question number 37. 1120 ml of N2O at STP was liquefied and the density of liquid is found to be 1.18 gram per centimeter cube. We have to comment on the volume of N2O which was collected. So if we look at the moles of N2O, we just have to divide the given volume upon the molar volume. Now at STP the molar volume is 22400 ml. So this will come out to be equal to 1 upon 20. We can now have the grams of N2O. It shall be equal to the moles into the molar mass. The molar mass of N2O is 44 gram per mole. So we have to multiply the moles with the molar mass to get the total mass. And now the examiner seems to be interested in the volume of the liquid and the density has been given to us. So we can find out the volume. We just have to find the ratio of the given mass to that of the density. So it is 44 upon 20 into the density given to us is 1.18. So we can have a value of 440 by 2 into 118. So this will give us a value of 220 by 118 or 110 by 59. So students, for this question, we have to mark the second option as the correct option. Let us look at the next question. Question number 38. Equal volume of 1 molar KOH and phenol are mixed. Then the heat evolved during the reaction in magnitude is. So if we talk about KOH, KOH is a strong base. But if we talk about phenol, phenol is a weak acid. Okay. So when these are reacted, the heat of neutralization shall be less than minus 57.3 kilojoule per mole, which is the heat of neutralization. Okay, but the examiner seems to be interested in the magnitude. So the heat shall be less than 57.3 kilojoule per mole. Okay. Now if you look at the options given to us, it is equal to the heat of formation of water from H2O and O2 in aqueous state. This is incorrect, students. If you look at the second option now, equal to the enthalpy of neutralization of 1 mole of KOH and half mole of H2SO4. This is also incorrect. This is the heat evolved when one equivalent of strong acid and strong base are neutralized. So this shall be equal to 57.3 kilojoule per mole as discussed before. If you look at the third option now, it is less than the heat of ionization of 1 mole water into H plus and OH minus aqueous. This is correct, students. To ionize 1 mole of H2O into H plus and OH minus aqueous, we need to provide a delta H value equal to 57.3 kilojoule per mole. So in magnitude, the evolved heat will be less than this. If you look at the fourth option now, it is obviously incorrect as it says that there is no evolution of heat. So if you look at the options which are given to us, we have to select option 3 as the correct answer to question number 38. Let us look at the next question. Question number 39. So we have been given a reaction sequence. So firstly, we have propane 1-ol. It is allowed to undergo dehydration and then addition of HCl. So the H2SO4 will convert it into an alkene. It will form propene and then the HCl will add to the propene, giving us 2-chloropropane. So this is our product A. Now this 2-chloropropane is first allowed to react with Mg in ether. So it will create a Grignard reagent. And in a parallel step, it is allowed to react with KCN in presence of ethanol. KCN in ethanol will cause SN2 attack on this 2-chloropropane and convert it into a nitrile. So this is C. Now the examiner seems to be interested in the attack of B on C. So the Grignard reagent will attack the electrophilic center present at the cyanide functional group, and it will lead to the formation of imine. So this is the product D which is obtained, and in the last step this D is hydrolyzed. So in hydrolysis this will convert into a carbonyl compound. So we're going to have the formation of this structure. So if you look at the options which are given to us, we can clearly see that we have to select the second option as the correct answer to this question. So let us look at the next question, question number 40. So we have been given a structure in which the examiner is first interested in the acidic hydrolysis. Students, we have imine and we have an ester. Both of them will be hydrolyzed in the presence of acidic medium. So in the first step, we're going to have the formation of beta keto acid. So this is our product A. So students, we know that beta keto acids, they undergo decarboxylation upon heating. So there will be a loss of a CO2 from the acid, and we're going to have the formation of cyclopentanone. So if we look at the options which are given to us, we can see that we have to select option 4 as the correct answer to this question. Let us look at the next question.